Today, we're diving into a story that claims to rewrite, get this, 2 centuries of mathematical history. We're going to look at whether it's a real breakthrough or just an unproven, though very interesting, theory. Let's get into it.
So let's start with a really big question. Imagine a math problem that's been famously impossible for generations. Like, it's a cornerstone of algebra. Now, what if somebody came along and said, "Hey, I solved it"? That's the huge, audacious question at the very heart of the material we're looking at today.
To really get why this claim is such a big deal, we first have to talk about a fundamental idea in algebra. Think of it like a giant wall that's been standing completely unbreakable for 200 years.
For 2 whole centuries, mathematicians have known exactly where the line is. Back in the early 1800s, they had it all figured out for polynomial equations up to the 4th degree. But then, in 1824, Niels Henrik Abel just dropped a bombshell. There is no single universal formula for the 5th degree. A few years after that, the absolute genius Évariste Galois explained why. And ever since then, Abel's impossibility theorem has basically been gospel in the world of algebra.
So the key idea here is something called solvability by radicals. Now, that sounds super technical, but the concept is actually pretty simple. It's just asking, can we find one universal formula, kind of like the quadratic formula you probably learned in school, that only uses basic arithmetic and roots to solve any equation of a certain degree? Abel's theorem famously says, nope, not for the 5th degree and anything higher.
And this quote from our source material just nails it. It perfectly captures this idea that has dominated math for 200 years, this belief that some problems are just fundamentally unsolvable, period. But what if that wall could actually be broken? Well, enter the challenger, who comes armed with what the source calls a revolutionary new theorem that just might tear that whole thing down.
So the source introduces us to Professor Murad Sultan Ezouidi, describing him as a visionary mathematician and independent researcher. It's really important to remember here that what we're about to go through are the claims presented in the source material we're exploring.
At the very core of his work is this, the EMST theorem. The author calls it a revolutionary breakthrough. It's a framework that claims to solve these super high-degree equations and, in doing so, directly challenges everything we thought was possible in math.
Okay, so how on earth does this theorem supposedly work? Right, let's try to unpack this.
The source lays out a 4-step process. First, you take the complicated polynomial and transform it into a new solvable form. Then, a recursive system kicks in to calculate new coefficients. This, supposedly, reveals the equation's hidden structure, and that leads to the final step, computing the exact roots. The big takeaway here is the claim that this method can systematically untangle a problem everyone thought was impossible.
And now, this is the moment of truth. This is where the source says, okay, here's the proof, showing us a dramatic before and after of one of these supposedly unsolvable problems.
Just take a look at this absolute beast of an equation. It's an 11th degree polynomial. I mean, this is the textbook example of a problem that, for 200 years, mathematicians have said is impossible to solve with a general formula using radicals.
And now for the big reveal. According to the source, the EMST method takes that monster and turns it into this. X plus 1 to the power of 11 equals 0. I mean, that is a stunning simplification if it's true.
So the bottom line is that this incredibly complex-looking polynomial has a beautifully simple solution, -1. The source presents this as a powerful demonstration of the method's ability to just cut right through all the noise.
So if, and it's a big if this claim holds up to serious scrutiny, what does that actually mean? Well, the source suggests it would be nothing less than a whole new era for algebra.
The author really doesn't hold back, saying, this work marks a historic moment in mathematics, the rebirth of solvability where impossibility once stood. That is a bold, bold declaration, framing this as a massive turning point for the entire field.
And it goes even further, calling the work, quote, a manifesto of innovation, proving that algebra is far from complete. The message here is pretty clear. The story of algebra is far from over.
And this isn't just about one specific problem. The author claims this EMST method can be used on a whole range of high-degree polynomials, from the 5th degree all the way up to the 19th. This isn't just a fix for one puzzle, it's a claim to have found a universal key.
So, we're left with this really tantalizing question. Has a single theorem just completely redefined the limits of mathematics?
Or is this a bold claim that still needs to survive the intense scrutiny of the global math community? The source material presents a compelling case, but, in the world of mathematics, the final verdict is always written in proof.